Okay, we're going to take care of lesson 4.1, and this is on page 95 in your book. And we're going to be using tables, graphs, and equations to represent non-proportional situations. So in lesson 4, everything in in lesson 3, everything in module 3 were proportional. This one is non-proportional. So looking at a graph, just to give you an idea, in module 3, everything came through the origin. In this lesson, in module 4, all the lines will start someplace other than the origin. So any kind of a line that we have on a coordinate plane in non-proportional will never go through the origin. They'll always touch the Y some other place. Okay, so on the Explore activity, keep in mind, and I've told you this before, keep in mind that the Explore activity is something that you should be doing. If we were in school, you do it with your group. But of course, since we're not, we just do these together now. And so it's going to be about bowling at Baxter Bowling Lanes. You're going to pay $3 for each game, and you're going to rent shoes for $2. So this is a real world situation, and we're going to solve this problem. The equation y equals 3x plus 2 gives the total charge y for one person to rent a pair of shoes and bowl X games at Baxter Bowling Lanes based on the prices shown. That was a long sentence. Make a table of values for this situation. So they want us to choose several values for X that make sense in context. Count by ones. So they're telling us to count by ones in this problem. So I'm just going to try to make this bigger. Why are you not cooperating? There you are. And what I'm also going to do, this table and this table are exactly the same. You see, they want us to just put two numbers here in step 1, transfer them down here into step 2, and then finish it off. But let's just do it all in step number 2. So this is just the same table, so I'm not going to pay much attention to that one. Let's just use the one at the bottom. Keep in mind they asked us to count by ones. So number of games 1, number of games 2. So let's do 3 and 4. So there we're counting by ones. I'm going to push this up so I have some space. Okay, so using the equation y equals 3x plus 2, we're going to find y for each value of x. So you can see on the first problem where they gave us a 1, they replaced x with 1 and they completed it. They don't show you all the steps. So they did y equals 3 times 1 is 3. We still have plus 2. And then y equals 3 plus 2, which is 5. And you can see they put the y equals 5 right here. So let's now use a 2 in place of the x. So we're going to use a 2. So I'm going to take this out and take this out. I don't have a whole lot of space, and I'll make it really messy if I don't. Okay, so this time we're going to use a 2. We're going to do 3 times 2. So 3 times 2 gives us 6. And then 6 plus 2 gives us 8. So when x is 2, y will be 8. Now let's try to use a 3 in place of the x. Come on, baby doll, get out of there. Good. Sometimes you gotta encourage it a little bit. So we're going to put a 3 in place of the x. So 3 times 3 gives me 9. 9 plus the 2 gives me 11. So this time it'll be 11. So one more time, and instead of using x for 3, we'll now use the 4. So we're going to substitute the x for 4 this time. 3 times 4 gives me 12. And then 12 plus 2 is 14. So while it's fantastic that we completed this table, what does this table actually mean? Well, if I play one game, if I bowl one game, I'm going to pay them $5. 2 games, I'll pay $8. 3 games, I'll end up paying $11. And 4 games, I'll pay $14. So this equation helps them calculate what to charge each person depending upon the number of games they play. So now we have the your turn problem. These are always fun. Francisco makes $12 per hour doing part-time work on Saturdays. He spends $4 on transportation to and from work. The equation y equals 12x minus 4 gives his earnings y after transportation costs for working x hours. Make a table of values for this situation. So you can see that the number of hours worked is blank. They want us to fill that in. The number or the amount of earnings is what we have to calculate. So just to keep everybody on the same page, let's put the same number of hours in. So I'm going to put a 3 in here. I'm going to make this 4. I'm going to put a 6 here and make this one an 8. So what I'd like you to do is to substitute in those values of x and find out how much Francisco will make. Now you're going to use this equation. That's where each value of x goes. So you put a 3 in, calculate, then put a 4 in, calculate, a 6 put in, calculate, etc. I am going to remind you also that when you have subtraction, we change subtraction to addition, and then we make this the opposite sign. So you'll be adding a -4 each time. So you're going to pause, complete the y, figure out how much he earns, and then come on back. Okay, so hopefully you tried this on your own, and perhaps you made a mistake, but that's okay. Mistakes are how we learn. I left my work up for problem 4, or excuse me, for x equal 4, so I could go through this with you. So I put my 4 in where the x is. 12 times 4 is 48, and I still have plus the -4. Since these two are not the same sign, positive, negative, I subtract and y equals 44. And that's where the 44 went. So I did the same thing for the 3. I put a 3 in, put a 6 in, and I put an 8 in. So if Francisco works 3 hours, he'll end up with $32. If he works 4 hours, he'll end up with $44. If he works 6 hours, he'll earn $68 in total. And for 8 hours, $92. Remember that he has to calculate what he makes per hour, but take away the 4 for transportation. So I'm going to guess that it probably costs the same to go to work and from work. So let's say that's probably like $2 each way. So maybe $2 on the bus to work and $2 on the bus coming back from work. That was how I would look at it. But I hope you did well. Okay, so moving on to the second explore activity. This one is about Mountain World theme park. So here's another real life situation, and we're going to talk about Mountain World theme park. The entrance fee, whoops, my thinker's moving. Okay, the entrance fee for Mountain World theme park is $20. So just to enter the park is $20. Visitors purchase additional $2 tickets for rides, games, and food. The equation y equals 2x plus 20 gives the total cost y to visit the park, including purchasing x tickets. So they want us to show that the relationship can have a constant rate of change, but not be proportional. I'm going to move this up a little bit so I can see a little bit better. There you go. Okay, so they want us to first complete the table. So 0. If I put a 0 in here for x, I'll have 2 times 0, which is 0, plus 20 gives me 20. So this is if I don't buy any tickets, but I still enter the park. I'm going to pay a total of $20. Now let's do the next one. This is a 2. So 2 times 2 is 4. 4 plus the 20, of course, is 24. Now use the 4. 2 times 4 is 8. 8 plus 20 is 28. If I come into the park and I buy 6 tickets, 2 times 6 is 12. 12 plus 20 is 32. I'll pay $32. If I come into the park and I buy 8 tickets, 2 times 8 is 16, plus 20 is 36. I'll end up paying a total of $36. Step 2, plot the ordered pairs from the table. Describe the shape of the graph. So let's do the first sentence. Plot these ordered pairs onto our table. On the table, onto the graph. Okay, move over. There you go. Oh, I got some old work up here I better get rid of. Okay, it kind of snuck up on me. So 0, 20. So starting at 0, you don't go right because it says move 0, go up to 20. And if you remember this, of course, if you were in class, I'm like, oh my gosh, I can't believe I stick my hand there. My little cursor was there. But that's 0, 20. Let's do 2, 24. So from the origin, 2, and then go up till you hit the line that has 24. Again, my apologies for that hand in the way. Okay, next we'll do 4, 28. 4, and go up till you get 28. So there's 28 right there. So let's make sure I get this right because I take my cursor away. I have to come back to it again. There you go. 6, 32. 6, 32. I like this one because I can see the 32 real easy. So that's where I'm going to go. And I put it in the wrong spot, of course. There you go. All right, and last one, 8/36. So 8 up to 36. Now it'll be right there. Keep an eye on that. 8/36. Now I put slashes so you can see them. I mean, you can put circles on yours. I just can't do a circle with my pen here. All right, then it asks us to, I'm happy with that. Oh my goodness sakes. This is supposed to be, well, you got the idea. They all moved all over the place. Sorry. Technology. Describe the shape of the graph. So if I were better at this whenever I enlarged it and stuff, I would say that it kind of forms a line. So points lie on a line. They're kind of in a row. They're kind of lying on a line. Now, I didn't put a line on here because it said plot the points. That's all I did, plot the points. Okay. Find the rate of change between each point and the next. Is the rate constant? So my rate of change, 24, it went up by 4, 20 to 24, x went up by 2. So I can say it went up by 4 on the y, up by 2 on the x, and that would equal 2. So I did the first 2 points. Let's do the next set of points. 28. It goes from 24 to 28. It went up by 4. From 2 to 4, it went up by 2. So again, I have 4 divided by 2. That rate of change is also 2. Now the next set. From 28 to 32, well, that goes up by 4. From 4 to 6, that goes up by 2. 4 divided by 2 is 2. Last set. From 32 to 34, this goes up by 4. From 6 to 8, it increases by 2. 4 divided by 2, once again, is 2. So the rate of change, whoops, is $2. And that goes up $2 per ticket. So for every ticket we buy, it goes up $2. Is the rate constant? Yes, it is. You'd say yes for the second question. Yes. Okay, next. Calculate y divided by x for the values in the table. Okay, so let's do that first, and then I'll worry about my explain when I'm done here. So y divided by x, 20 divided by 0. So I hope you remember that 20 divided by 0, we are not allowed to divide by 0. So I would say that 20 divided by 0 is undefined. Next we have 24 divided by 2, and that would give me 12. 28 divided by 4, that would be 7. 32 divided by 6. So 32 divided by 6 Remember, fractions are fancy division. If I divide these both by 2, I get 32 divided by 2 is 16. 6 divided by 2 is 3. And I'm going to leave it as that improper fraction. This one I can't divide and get a whole number. So I'm just going to leave it as the improper fraction. And then we have 36 divided by 8. And again, if I take 36 and divide that by 8, what can I divide these both by? I can divide them both by 4. So 36 divided by 4 is 9. 8 divided by 4 is 2. So I'll leave this one as 9/2. So I calculated y divided by x for each of them. Then it says, explain why the relationship between the number of tickets and total cost is not proportional. Remember, this was called the constant of proportionality in Module 3. We had proportional problems, and that was called the constant of proportionality. And when we calculated that, they were always the same. This time, they're not. So I'm going to explain why it's not proportional. The ratios are, not equal. And I can also talk about the graph. Oh, what are you doing? Come back here. And the graph does not go through the origin. So I can view where my points are, although this is pretty lousy because my points keep moving around. Okay, that's kind of where they were, but not really. So my points aren't moving with my page. Sorry about that. So, but I can see that it's not going to come through the origin. So that's another reason why it's not proportional. Okay, so would it make sense to add more points to the graph from x equals 0 to x equals 10? And would it make sense to connect the points with a line? Explain. So if you look back at the table uses x equals 0, x equals 2, x equals 4. It's almost as if you have to buy even number of tickets. But you can add more points to your graph because you can buy odd number tickets. That is, you can buy one ticket. You can buy just one ticket. And if you buy one ticket, you'd have x equals 2 times 1 plus 20. So if you bought one ticket, you would end up paying $22. So you could add the point. Oh, wait, maybe I should say yes first. Okay, so yes, add points. One ticket is $22. 3 tickets. So 2 times 3, put a 3 in there this time. So 2, what are you doing? Oh, it's processing. Oh my goodness. So 2 times 3 tickets is 6. 6 plus 20 would be 26. What about 5 tickets? So 2 times the 5 would give you 10. 10 plus 20 would give us 30. I'd end up paying $30. How about 7 tickets? That's an odd number. We didn't use that. 2 times 7 would give us 14. 14 plus 20 would give us 34. And the very last one we could use, we could say 9. 2 times 9 is 18. 18 plus 20 is 38. So 9 tickets would be $38. So I could add 1, 2, 3, 4, 5 more points to that graph. Then it asks, would it make sense to connect the points with a line? Explain. Now, many students see that graph on the other side here in the last frame. They see that graph, and now we have all these points that form a line. And the students will say, yeah, you know what? Let's put those all together. Because we just put points down. We had the points from the table. We had the points that we just added here. Just draw the line and be done with it. But actually, that would be a mistake. So you would say, no, don't connect those. You see, the number of tickets that you buy has to be a whole number. 1 ticket, 2 tickets, 3 tickets. Along the bottom of this, they had 0, 1, 2. They didn't have the even or the odd numbers, just the even. But I'm going to put them all down so you can see them. And so you can buy no tickets, 1, 2, 3, 4, but you can't buy a number in between 1 and 2. Can you imagine walking up and saying, you're at the movie theater, you say, I want 1.5 tickets. I want to be right here. Now, how can you buy a half ticket? You can't buy a half ticket. So you can't buy half tickets. So tickets must, come on, baby doll, must be a whole number. I can't buy a fraction of a ticket. I can't buy a negative ticket. None of that stuff will work. So we have to make sure that these points don't touch. Because if I made a line here, that means that everything in between would count. But we can't buy positive tickets. It's kind of a tricky question. And it's more, now you understand more a bit of it when you see it. So now it's easier to understand some things can't be fractional. Okay, so here's an additional example. The equation y equals 2x plus 5 gives the total height of a plant y in an experiment that was 5 centimeters tall at the beginning of the experiment and grew 2 centimeters each day. Make a table of values for this situation. So you're in science class and the teacher wants you to do a little experiment, and they give you a plant, and the plant is 5 centimeters tall. And then they ask you to measure the height of the plant each day. And then you calculate the new height. So each day that passes is going to be X. And it's supposed to grow 2 centimeters every day. So you can measure the height. Make a table of values for this situation. Now I want to make sure that we all have the same table. So ta-da! Here's a table. So I'm going to use, for number of days, let me change this. Yeah, okay. I'm going to use for my number of days, X, 1 day, 2 days, 3 days, 4 days. So I'm going to put 1 in for the value of X. So 2 times 1 is 2. plus 5 gives us 7. So I get the plant on Monday. I come in, 1 day has gone by. My plant is now 7 centimeters tall. Now we're going to use day 2. 2 times 2 is 4. 4 plus 5 is 9. So when I come in the following day, on Wednesday, 2 days have now gone by. My plant is now 9 centimeters high. Day 3. 2 times 3 is 6. 6 plus 5 is 11. Now let's use day 4. Day 4, 2 times 4 gives you 8. 8 plus 5 is 13. So that tells me on day 4, my plant should be 13 centimeters tall. Okay, so now we're going to have representing linear relationships using graphs. A linear equation is an equation whose solutions are ordered pairs that form a line when graphed on a coordinate plane. So a linear equation, it's an equation that forms a line. And it's going to be in this form, y equals mx plus b. So this equation, y equals mx plus b. M is going to represent your slope. B is going to represent the y-intercept. Now in Module 3, all we had was mx because plus b was always 0. What the plus b is going to control is where your line touches the intercept. Okay, so if your plus b is a 0, like it was in Module 3, that's going to give you a line, a graph that goes through the origin, if this b is a 0. But in Module 4, the b is going to be a different number other than 0. It could be a positive number, it could be a negative number, but it's not going to be 0. In that case, what it does is it moves the line up on the y-axis if it's positive, or perhaps if b is negative, it moves it down below. So let's pretend that there was a line down here. It moves it down below. We'll get more into that, but it's very important for you to understand that everything we're doing in Module 4 is not proportional. So our line is not going to go through the origin. It's going to touch the y-axis some other place. Okay, so here we are with another example, and this is about the Douglas fir tree. It's a type of tree that has green on it all year long. You could even have one in your house now this time of year. The diameter of a Douglas fir tree is currently 10 inches when measured at the chest height. Over the next 50 years, the diameter is expected to increase by an average growth rate of 2/5 inch per year. The equation y equals 2/5 x plus 10 gives y the diameter of the tree in inches after x years. Draw a graph of the equation. Describe the relationship. So let's take a look at this Douglas fir piece that they cut. So the diameter is going to go from one edge all the way across to the other side. That's your diameter. The diameter also goes through the center. So starting off this problem, the diameter is going to be 10 inches. If you look at the rings of a tree, it tells you approximately how old the tree is. When the rings are far apart, this was a good growth year. So what it's telling you is that it had plenty of sunlight, it had plenty of water, there were good nutrients in the soil. And when the rings are closer together, like in here, they're close together, these were poor growth years. Perhaps there wasn't enough sunlight, there wasn't enough soil, nutrients, there was a lack of water. So that's why you have different ring widths in a tree. They ask us to make a table. Choose several values for x that make sense in context. To make calculations easier, choose multiples of 5. So they chose 0 for the very first time they measured the tree. It was 10 inches in diameter. Then they chose 10, 20, 30, and 50 years. And they put a 0 in. And so on the equation, let me scooch down. There you go. So they put a 0 in for x. So 2/5 times 0 gives you 0, plus 10 is 10. Then put a 10 in. 2/5 times 10 will give you 4, and 4 plus 10 is 14. 2/5 times 20 gives you 8, and 8 plus 10 is 18. They do the same thing. They plug in a 30 and get 22 inches. They put in a 50 and get 30 inches. So they made the table for us, but they're really telling you that if you had to do this on your own, you'd choose numbers here that make sense and then calculate your y's. Plot the ordered pairs from the table. So 0, 10. So I'm going to go away. I'm going to change this so you can see the color a little easier. So here's 0, 10. Then plot 10, 14. Here's 10, 14. Plot 20, 18. Here's 20, 18. Plot 30, 22. Here's your 30, 22. And finally 50, 30. Here's 50, 30. It says draw a line connecting the points to represent all possible solutions. So there's a line that's drawn. Remember, X is in years. I can have year 1, 2, 3, 4, 5, etc. That's why all the years in between will count. I can even have partial years. I can use months. I can use like one year and 2 months. Well, that's going to be in here. 1 year and 2 months. That's all going to be included in here. So this makes sense in connecting the line because you can have a partial year. And then they ask us to describe the relationship. So what they said here was the relationship is linear, so it forms a line, but it's non-proportional. It doesn't go through the origin. So it's a linear, it forms a line, it's non-proportional, it doesn't go through the origin. This is much better if you do this whole thing yourself, but again, they have it completed for you, so we just kind of explained it. Okay, so here's the your turn problem. And it looks like I have a little bit of stuff on my graph here. Get that out of the way. All right, so your turn. So put a -1 in for x. That'll be -2 times -1. Calculate that and add 1. Put your answer. Do the same for 0, 1, and 2. So you want to put those numbers in and then come back. Don't do anything else. Just calculate the numbers for y. Don't touch the graph in case we make a mistake. Put the numbers in here first, then come back. Okay, so I left my work up here whenever I put in -1 for the x. There's my -1. So -2 times -1, a negative times a negative is positive. 2 times 1 is 2. 2 plus 1 gives you 3, so I put a 3 in. Then I put a 0 in its place. I found 1. I put a 1 in. That answer was -1. I replaced x with a 2, and I got a -3. Remember, once you replace it, add a +1. Now, if you got these correct, plot these points on the graph and then come on back. So stop, plot the points, come on back, and we'll compare. Okay, so I put -1. I came over -1, 3, and then this is 0, 1. The next one I did +1, -1, and the last one was +2, -3. So that's where your point should be. And then get yourself a nice straight edge, which I have none that'll fit on here. It's hard for me to use a straight edge on this screen because if I touch it with a ruler, then I can't make any lines. So I'm going to just eyeball this up the best I can. And your lines should look something like that, but better. Okay? So that's kind of how it should look for your turn. Okay, so this is the guided practice, and this can be found on page 98, I believe, 98. And we did this on Tuesday in class. And if you joined us, we actually did a pretty good job there. A lot of students were really into this, especially problem number 1. It's kind of an easy one to do. So I'm going to take -2, put it in here for x, and multiply it by 2. After I multiply it by 2, I add 5. So just to show you what we did in class, y equals 2, and I've replaced that x. So I'm going to scooch this up so I have some more space because I run out of space fast. So replace x with a -2. So y equals, well, negative times a positive is a negative, and 2 times 2 is 4. And now I have -4 plus 5. So I have 1, 2, 3, 4 negatives. I have 5 positives. So these armies are opposite of each other. They're against each other. So they wipe each other out. They match up and wipe them out. And all I have is a +1 remaining. So 1 is my answer. Do the same thing with -1. Let me just get these out of the way so they're not bothering me, because they bother me. Okay. All right, so -1 times 2 is -2. -2 plus 5, 2 negatives, 5 positives. That will give me 3. Okay, 0. Put a 0 in here. 2 times 0 is still 0, plus 5 is 5. And now a 1. 2 times 1 is 2. 2 plus 5 will give you 7. And now put in a 2. 2 times 2 is 4. 4 plus 5 would give us 9. And that's how I complete my table. Okay, problem 2. Problem 2 is y equals 3/8. I'm going to multiply that by the x value, minus 5. Now recall that we don't use subtraction. Change your subtraction to addition, and that 5 becomes a negative. So the first number I'm going to place in here is a -8. Now, since I'm going to multiply a fraction times a whole number, I'm going to make that whole number into a fraction also by simply putting a 1 beneath it. So now I'm multiplying two fractions together. So before I multiply, I'm going to reduce my fractions. I was taught this back in 6th grade and 5th grade. I'm reducing my fractions. So I can divide both the 8 and the -8 by 8. So 8 divided by 8 is 1. -8 divided by 8 is -1. So 3 times -1 is -3. 1 times 1 is 1. I'm not going to make this into a fraction. There's no need to. I can make it back into the whole number, back into the integer, by taking the 1 away. So there's no need for this to be a fraction anymore. Plus -5. So -3 plus -5 will give me -8. Okay, so let's try the next one, 0. Now it's nice whenever you're multiplying by 0. When I multiply 3/8 times 0, 3/8 times 0 is simply 0. Plus -5 would give me -5. So certainly using those zeros is easy. Next, we'll use an 8, a +8 this time. I can still reduce these two, dividing them both by 8. 8 divided by 8 is 1. Divide 8 by 8, and you get 1. 3 times 1 is 3. 3 plus -5 is -2. Again, there was no reason to use 1 times 1 and make this into a fraction. I need the whole number here, so it makes life easier. However, I've now run out of numbers for x. But I see the pattern forming here. I see that I keep adding 8. So I'm going to add 8 and make this one a 16. Add 8 and make this one a 24. Okay, we're back in business. So we'll take out this 8. And this time we'll use our 16. So I'm going to divide both by 16. So 8 divided by 8 is still 1. 16 divided by 8 is 2. 3 times 2 gives me the 6. You don't need to multiply the 1 times the 1. 6 plus -5 is 1. And now one last problem is going to be the 24. And of course, we're going to reduce that 24. We divide them by 8. 8 divided by 8 is still our 1. 24 divided by 8 is 3. Multiply the green 3 by the black 3, you get 9. And 9 plus -5 is 4. And that completes our table. Okay, for 3 and 4, they want us to explain why they're not proportional. On 3, it asks you to calculate y divided by x first. So you're going to take y and divide it by x. So 3 divided by 4 is undefined. Two divided, no, 2. 7 divided by 2, I'm just going to leave that as an improper fraction. 11 divided by 4, I'm going to leave that one as an improper fraction. 15 divided by 6. So I'm going to do 15 divided by 6. I can reduce those both by 3. So I'm going to end up with 5 halves. And then 19 divided by 8. I'm going to leave that because I can't reduce it. Now, some people, they just want to jump on the calculator and say 7 divided by 2 and get a decimal. 11 divided by 4 and get a decimal. 15 divided by 6 and get a decimal. So you can put decimal answers down here. Just be careful because sometimes they're non-repeating or never-ending decimals, non-terminating decimals. So don't hurt yourself by making them into decimals. I just put them as a fraction, as a ratio. If I can reduce them, I do, and if I can't, I can't. So it's going to ask you about why they're not proportional. And we can just say the ratio, we had a problem like this earlier. The ratio of y divided by x is not, you can say not the same. I'm going to say not constant. It's kind of more mathy, is not constant. Okay, next one, problem number 4. Why is this not proportional? Oh, the graphs are the easiest. If you follow the line, it doesn't go through the origin. Therefore, it's not proportional. So you can say the graph is a line, but it does not pass through the origin. Easy enough. Okay, number 5. Complete the table for the equation, then use the table to graph the equation. So first complete the table. So I'll get you started. Y equals x minus 1. Remember, that's going to be plus a negative. So replace x with a number and then just add a negative 1 to it. So just complete your table and go no further. Okay, so if I put a negative 2 in, I'll have negative 2 plus negative 1, that's negative 3. A negative 1, negative 1 plus negative 1 gives me negative 2. 0, 0 plus negative 1 gives me negative 1. 1, 1 plus a negative 1 gives me 0. And a 2, 2 plus negative 1 is 1. So these are the numbers you should have. If you made a mistake, just fix them. And then let's plot these 5 points over on the graph. And then come back after you plot them. Don't draw the line yet. Come back after you plot them. We'll check. All right, so these are your points. Negative 2, negative 3. Negative 1, negative 2. 0, negative 1. 1, 0. And 2, 1. So if you agree, get your straight edge and draw it. I'm going to try again on this one. Let's see. It's going to go right here. Woo! There you go. That's your line. That's what it should look like. So your lines shouldn't end at the points because the lines are continuous. They should go off the end. Okay? Okay, here's your essential question. How can you choose values for x? Well, making a table of values representing a real world situation. So if it was about the tickets for the amusement park, remember that one? There were certain numbers we could choose and numbers we shouldn't choose. The tree, whenever the tree, told us to choose some numbers for the tree. So what kind of values would you choose for X if you had to make your own table? Think about that for a minute and come on back. All right, so this is what I decided. Choose values of X that make sense to the problem. For example, cars sold must be a whole number. So if you're talking about cars, you can't have, a half a car or a decimal of a car. You have gallons of milk that you sell. That has to be a positive number because gallons of milk aren't negative. I mean, you have a gallon or you don't. And they of course, would be whole numbers also. Just something like that. As long as you have down, choose values of X that make sense to the problem, um, that's really going to be it. And it's nice to have an example. For example, you could have down games played must be a whole number, something like that. Okay, thanks, guys.